I'll leave the floor to you. Thank you so much for being here again, all of you, and I wish you a good session with Michaela.
Okay, so I actually find it really difficult to speak with this thing. Can you hear me, or should I use it?
No, we can hear you.
Can you hear me at the back? Yeah? Just if at one point I start mumbling into myself, let me know, because this makes me very self-conscious, and I will probably just forget to use it anyway. How do I turn this off?
You don't have to turn, just turn it down.
Okay, so first of all, wow, there's so much knowledge and expertise in the room that I think actually half of what I'm going to go through is probably stuff that you already know. Last night we had a corporate session and I was standing in here actually speaking to about 50 CEOs and businessmen, and I think this is a very exciting crowd and totally different. So I feel really honored to be in front of all of you, and really curious to hear about all of the work that you're doing. And actually really excited because I think this is a super interesting and exciting opportunity for all of you to learn from each other as well. If I speak too fast, please tell me. I have a tendency to get very excited about certain things and just start escalating and going away from what I'm saying and going too fast with it. So super informal. I'm used to teaching. I also teach environmental systems in front of normally 16-year-olds, and with them it's always very interactive. So I'm going to ask you questions. I want you to feel free to just put your hand up and say the first thing that you think. If it's wrong, it's okay. If it's right, it's even better, whatever. This is a super kind of open, safe space. We're all here for very similar reasons, I think. Okay, so let's get started. I'm going to first of all go through a brief overview of climate change and climate change impacts. I'm going to keep it as short as I can. I have a ton of slides, but I think you're all actually very clued up on what I'm going to talk about. And then hopefully we're going to start talking to each other a lot and see which ways we can use tools that we all have and skills and expertise that we all have to try tackling various different issues. Okay, so welcome to the Anthropocene. The Anthropocene is a word which for me makes a lot of sense. I'm Greek, so anthropos means human, scene is a period of time. So we are now in the Anthropocene, which is the geological era following the Holocene, in which humans have had such an impact on our planet that in thousands of years to come, if geologists had to look back, they will still be able to see the impact that we've had. This is quite self-centered, on the one hand, to think that we have the potential to have such an impact on a planet that's 4.5 billion years old, and on the other hand, kind of terrifying that we as an international scientific community have agreed that we've had such an impact. The ways in which we have been mining, the ways in which we're using and getting rid of our waste, the impact that we're having on the atmosphere, all of these reasons are causing us to be in this new era called the Anthropocene. So I'll give you a small introduction. Hopefully the sound is...
This was the story of how one species changed a planet. The latest chapter of our story begins in England 250 years ago. Fueled by coal, then oil, several brilliant inventions appeared. They ignited the Industrial Revolution, which spread like wildfire through Europe, North America, Japan, then elsewhere. The great railways, then cars and highways, connected people across the globe. Medical discoveries saved millions of lives. New artificial fertilizers meant we could feed more people. Population rose rapidly. But this was nothing compared with what was to come. The 1950s marked the beginning of the Great Acceleration. Globalization, marketing, tourism, and huge investments helped fuel enormous growth. People swarmed to cities, which became even more powerful engines of creativity. In a single lifetime, the well-being of millions has improved beyond measure. Health, wealth, security, longevity, Never have so many had so much, yet 1 billion are malnourished. In a single lifetime, we have grown into a phenomenal global force. We move more sediment and rock annually than all natural processes, such as erosion and rivers. We manage 3/4 of all land outside the ice sheets. Greenhouse gas levels this high have not been seen for over 1 million years. Temperatures are increasing. We have made a hole in the ozone layer. We are losing biodiversity. Many of the world's deltas are sinking due to damming, mining, and other causes. Sea level is rising. Ocean acidification is a real threat. We are altering Earth's natural cycles. We have entered the Anthropocene, a new geological epoch dominated by humanity. This relentless pressure on our planet risks unprecedented destabilization. But our creativity, energy, and industry offer hope. We have shaped our past. We are shaping our present. We can shape our future. You and I are part of this story. We are the first generation to realize this new responsibility. As the population grows to 9 billion, we must find a safe operating space for humanity, for the sake of future generations. Welcome to the Anthropocene.
All right, so yeah, welcome to the Anthropocene. It's exciting, it's terrifying, but I think in this room there's a lot of examples of the ways in which we can collectively start solving these issues. So, a few significant ideas. Climate change is something which has been happening on this planet forever. Climate change is normal. Climate changes all the time. When we talk about climate change as an issue, it's about enhanced climate change. And that's what you can see. Oh, why can't you see my slide? This. So climate change is normal, and now we have enhanced climate change, which is over the last 50, 60 years especially. The impacts of it are widespread and significant and incredibly connected. So the first part of the session will be talking about those impacts and really thinking about the ways in which they connect to one another. Resource use and consumption trends are increasing. So with more people and with a growing global economy, people are using more stuff. We want more, we have to get rid of more. So all of these things are putting pressures on our planet as well. And solutions are on many scales: individual, local, national, global. I'll get it. I'll learn it very quickly, I hope. And most importantly, everything is connected. And this, I think, is really the only takeaway that I hope everybody is able to kind of think about afterwards and with everything that you're doing, because the impacts from everything that we do increase with every step. So, a little bit of the basics, and I'm sorry if this is repetitive. What is the difference between weather and climate? Hands up. Yes?
Weather is a condition of day
Yeah.
within 24 hours, and it is a long term. It's about 3 to 4 months. Certain kind of weather conditions which persist for a certain period of time.
Excellent. So weather is the day-to-day changes. It's rainy today, it's sunny tomorrow. Oh no, it's cloudy and I wanted it to be sunny. It's when you wake up in the morning and you decide what to wear. Climate is the average weather conditions over a period of time. It's actually normally over 30 years that we measure climate. So it's really important because often you hear people saying, climate change is not real. It's snowing right now. What is this global warming you're talking about? But actually we really need to look at the average trends. We need to look at the average because that's what's going to give us a clear indication of what's happening. And these are the kind of things that I think often, as someone who wants to talk to people about these issues, you come across them all the time, and you should be able to quickly say, but actually, no. Let me tell you why. So yeah, weather daily changes, climate average pattern over 30 years. And climate change, we often talk about greenhouse gases. There are 4 of them, mainly, that we're going to focus on today. water vapor, nitrous oxide, methane, and our favorite friend, carbon dioxide. Where do these guys come from? How do we put these into our atmosphere? What kind of things? Activities? Burning fossil fuels. Where do we burn fossil fuels? Industry, factories. What did you say? Vehicles. Power plants. Anything else? Agricultural activities. What comes from agriculture? Methane. Cows farting. A giant one. So greenhouse gases come from a variety of sources, and humans are increasing the amount of greenhouse gases in the atmosphere. And you probably also are very aware and know this diagram very well too. So what is happening here? We have the sun emitting radiation. That bounces back out. We have our planet here, and there's a layer around our planet, which is our atmosphere. Naturally, we have greenhouse gases in our atmosphere. The issue is that with increasing greenhouse gases, the radiation that is meant to bounce out, more and more of it is getting trapped and is increasing the global mean temperatures. That's a very basic explanation, but I think all of you are pretty aware of what's going on, so I'm going to move on. No? Yes, okay. Pause. This is, and I think it's important that not only to be able to quickly connect with people and the questions that they have for you and the ways in which they'll say, but it's not true because da 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 da, but also to have resources. So I'm super happy to share any of the slides or any of the animations because I think they're really useful in showing in a quick way what you're talking about. So this one's a really good one because if we're talking about greenhouse gases and we're talking about carbon in particular, it shows in a quite simple but clear way what has been happening since the 1750s on this planet. So we have this world map. Here is our date, 1778 is where I paused it. And here is CO2 concentration. So where is CO2 present and being emitted? Blue is a little bit, red is a lot. The UK, India, Africa, you can see the rest of the map. And watch what's happening. Watch what's going on according to the changing time. Oops, wow, what is going on? Sorry. All right, so we're starting in the late 1770s. It's in the UK. CO2 is being emitted just here. It's barely anywhere else. There's a little tiny dot in France that I can see here, but it's really not that much more. 1830s, 1840s is spreading to Europe. 1850s, it's kind of all over Northern Europe and a little bit in the US. But still at the early 1900s, now we're not really further than the US and Europe. A little bit in India. 1920, we see some blue here. There's also Japan and whatever's going on here. 1950s, it's a lot more than when we started 100 years ago. And then quickly you can see by the 1980s, 1990s, look how fast the color is changing. And look at what a different map we have today. This is 2006, so this is not even totally up to date. But you can see that where we started with this tiny little blue dot on this really insignificant island, suddenly, all over the world, we have a totally different picture. What does this mean? What does this really show us?
CO2 has increased like from 1700s to today.
Yes, perfectly true. CO2 has increased from the 1700s till today. What else?
Industrial Revolution.
The Industrial Revolution. Okay, so we can ascertain that that's because of the Industrial Revolution. Yeah, it started in the UK, grew from Europe. What else?
Globalization.
Globalization. Why do you say that?
Because now global economy, we are putting more emphasis on global economy, global consumption. And this economic progress is happening. And the developing nations, they want to be developed right now. So they have their priority on economic progress than on environment.
Yeah, okay, great. So there's a lot in that. So globalization has meant that people want to strive for a certain type of development, And the way in which we develop is by burning fossil fuels, because that's how we get energy. And so as the world wants to become closer to a certain ideal, the ideal of having whatever they were having in the UK and continue to have in the developed world, quickly, actually, I was going to say slowly, but actually very quickly, this has spread, and that has also meant the spread of where emissions are being emitted. Anything else?
Development of industrial transportation.
The development of industrial what?
Industries.
Of industries, yeah, the development of industries spread. And I think it's also really important to note that for the first 100 years, it was really here, right? We were looking at the color being around this area. And then there was a sudden shift. And I think that's really important because we often talk about who has the responsibility to act. And I think we have, it's talked about in terms of a common but differentiated responsibility. So we all have a responsibility to act towards climate change, but it's differentiated. And it's differentiated within this room, it's differentiated within this city, and it's differentiated across the globe. And I think that's really, really important to acknowledge because we cannot expect countries who have suddenly got a little bit of blue right now to act in the same way as the UK, for example. And so that plays into how we think about what we do to act, what we do in terms of international policy, but also the fact that it is all over the world. And because everything is connected, we do need to act. We need to act here in Kolkata, we need to act in Athens, we need to act in, I don't know, wherever else, everywhere else. Okay, so another important tool that you have is showing that, yes, change happens, change is certain. Climate has been changing for centuries. This is 400,000 years before today, and carbon dioxide goes up and down, up and down, up and down, up and down, until we get to about here. And then it goes up and up and up and up and up and up and up, 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 up. And there's no down. This is a huge amount of up for no down compared to all of these centuries before. So what we see over the last 50, 60 years is an incredible change in the amount of CO2. And this is a really important graph because it really highlights how, although it is normal, we're doing it to a hugely more than normal extent. Okay, so what really happens? Why does it matter if greenhouse gases increase? Why do we really care? Well, first of all, if greenhouse gases increase, we have increasing temperatures. We've talked about that. Second of all, we have an increasing extreme weather frequency and intensity change. So frequency means we have extreme weather more often. So instead of having something once a month, you have it twice, or 3 times, or 4 times, or once a year, now you have it several times over the year. Intensity means how strong it is. So if we look at how storms are categorized, if we look at how much flooding has occurred, how many millimeters, that's the intensity. And with increasing greenhouse gases, we're going to have more and more extreme weather more often. And finally, we're going to have increasing sea levels. So what I'd like to do now is delve into these 3 areas and look at the impacts of what does it mean to increase temperatures. We hear about 2 degrees or 1.5. What do these things really mean for us on a human, personal level? What does it mean to have extreme weather and increasing sea levels? So, starting with temperatures. The IPCC is the Intergovernmental Panel on Climate Change. They got together a group of scientists from all around the world, about 1,300 of them, and they concluded with more than 95% certainty or probability that human activities over the last 50 years have warmed our planet. Getting together 1,300 scientists and getting them to agree is really hard. You can't get together 2 scientists to get them to agree. So 1,300 of them, independent scientific experts, all say that this is real. They all say that over the last 50 years, we with our actions, have caused a warming. That's important because I think it really shows that it's not something like Donald Trump says, made up by the Chinese. This is a consensus globally. These are not independent scientific experts only from New York City. These are independent scientific experts from all over the world. And they're agreeing on this. And they have data to back that up. So NASA and the Hadley Center and this place called NOAA and the Japanese Meteorological Agency, and I could have put 10 other things on this graph, have all seen temperatures change since the 1880s. And if you look at the lines, they're all seeing pretty much the same thing. There's not the Japanese Meteorological Agency seeing something like this. Everybody has the same results. From the temperature recordings that they've had from across the world, it all looks pretty similar, right? So, let's have a look at what that looks like in a graphic. We're starting at 1880. The blue is colder, and going towards yellow and red means hotter. Again, watch the dates and watch what is happening as time changes. We're looking pretty blue, patches of red, but that's kind of normal. 1920 is a little bit more orange, a little bit more red at the top. That's a little worrying for the Arctic. 1950s, okay, Antarctica a little troubled, but it's going up and down. Suddenly we're getting to the 1980s. We see more and more yellow being the dominant color. 1990s and 2000s, suddenly it's yellow and red all over the place. We started with a blue Earth, with a patch of yellow, and we're ending at a dominantly red and yellow Earth. This is us getting hotter. It is getting hot in here, and that's really a little bit scary. Okay, I need a volunteer.
Okay.
Yeah. Oh, yeah. Come on up.
I'm going to disclose my birth year.
Sorry?
Am I going to disclose my birth year?
Yes. That's exactly what I wanted to do. Okay, so let's make this a little bit more real.
Okay.
Enter your birth year.
1962.
1962, okay.
Ancient, no?
So let's see what happens. Okay, so you were born in 1962. Temperatures since have risen 0.75 degrees Celsius since the Industrial Revolution, just so that we can kind of place it. 0.75 degrees, quite a lot. Some of that was in your lifetime. So the last decade was 0.5 degrees hotter than the decade before you were born. 0.5 degrees hotter than the decade before you were born is quite a significant difference.
I can see the graph there.
Yeah, you can see it, exactly, you can kind of see it. So this is where you were born, and this is what temperatures have been doing in your lifetime alone.
That's something.
It's quite something, yeah.
Yes.
Let's see what happens if we press the little button again. What happens next depends on future carbon emissions and how sensitive the climate turns out to be. The orange area is the range. So with science, we always have a range because if we're looking at predictions, we have to have a little bit of leeway. But this is what has happened in your lifetime so far, and if we continue in the way that we're going right now, this is what's going to happen for the next 40, 50 years. Okay? If you live another 40 years, you could see a world 2.9 degrees Celsius above pre-industrial levels. If emissions keep rising, that's higher than the agreed global safety limit of 2 degrees. That's only in the next 40 years. Oops. A child born today, so if any of you are thinking of giving birth today, could see rises up to 6.3 degrees Celsius in its lifetime, which is enough to bring catastrophic effects all over the world. We don't ever want to be talking, I don't want to be in a 6.3 degree world. That is terrifying. 6.3 is ridiculous. So we see the general trend, right? And it's important. I know that this is scary, and it's actually, I find it really difficult to actually give these talks because I don't like being the person to make people feel really terrible. But all of you are working in these fields, all of you are engaged, and it's really important that you're able to truly grapple with what we're working with. I've been talking about climate change and thinking about climate change since I can remember. It's been in my school curriculum. I was born in '92 when we talked about climate change on an international level. And it's often easy for me to forget also. So doing these things and doing these things in the communities that you work with, doing these things with the people that you engage with is really impactful. How do you feel?
It's definitely scary looking at all these figures, and I'm not worried about my future because I'm ancient, as I've told you. But my children and grandchildren, I have a 1-year-old grandchild.
Yeah.
So I'm worried about his life, definitely.
Yeah, I can imagine. Well, thank you for sharing your birthday. Okay, let's go back. Okay, so they're increasing. Let's see what it means. A few of the ways in which we will be impacted are listed here. We're going to have impacts on food. We're going to have impacts on water, ecosystems. All of these things are going to change gradually with how much temperature increase we have. So you can see up here is a 1 degree, 2 degree, 3 degree, 4 degree, 5 degree. And there's various scenarios that have been created for these. So if you want to know more, I would read into all of the IPCC stuff, the assessment reports. They come up with various scenarios of what this means. Let's go through them a little bit. Food production. So with global temperature change, which is what we have here, so 1 degree, 2 degree, 3 degree, 4 degree change, this graph shows us what yield changed. So how much more, if it's going up, or how much less from what we produce now, okay? So let's take the green one. Asia rice. With an increase of 1 degree, it's gonna go up a little bit. Why would that be? What do we need to grow food? Water, soil. Plants do well with heat, so with a little bit of a change, some foods might increase a little bit. Not significantly, but it is possible that yield might increase to start with, but it starts going down again. So this is Asia rice. With 2 degrees, it started to go down, down, down. Here we have US soybean in blue. That one's also going up a little bit. In the US, there's areas which a little bit more heat might help the growing of soybean. But then as we reach the 1 degree line here, it starts going down. Here, the purple line, India wheat. India wheat does not need us to be any hotter. It doesn't benefit at all from any increase in temperature. It's pretty hot here, so it's going down, and then once it reaches 1 degree, it's going down drastically and ends up with 4 degree rise would lead to a minus 70% change in yield. 70% less yield. With such a rapidly growing population, that's pretty scary. Sorry?
There will be world war. We will fight each other.
There will be famine.
There will be war, there will be famine. Yeah, these are really important knock-on effects. If we don't have food and water, we start doing some pretty horrible things. And think about who will be the most affected. So vulnerability changes depending on your socioeconomic situation. Climate change is not a fair thing. Climate change is not just. Climate change affects people without thinking that it should be done equally. And so yeah, totally. Food wars, water wars, these are things which people are worried about, thinking about, talking about. Okay, let's move on from food. Oops. So agriculture is dependent on soil fertility. As we have increased droughts, it leads to soil erosion. These are the ways in which you know that there's knock-on effects. So we don't just talk about it being a drought, we also talk about it being a drought, which leads to soil erosion, which leads to decreased food production. Couple that with increased temperatures, less water, less space, and la la la. Oh my god. Increased temperature also leads to issues for livestock. People depend on livestock for their they're living. They depend on that for their food. If livestock can't find water, if they can't find grass, if they can't find anything to feed on, they're going to have a lot of issues. And in the sea, fishermen, seas are delicate ecosystems. Corals really need a very, very specific temperature range. So if we are seeing less phytoplankton, which is at the bottom of the food chain, then we're going to see knock-on effects on the rest of that food chain. Let's have a look at what it looks like. Here's the present day. This is from the World Food Programme. The UN has made this nice graphic for us. The darker means more food insecurity, the lighter color means less food insecurity. Here we are in India with an orange. Let's go to 1950s. We've gone a little bit darker, but if you look at the change, we've not only gone a little bit darker in India, we've gone a little bit darker everywhere. And then if we go from the 2050s to 2080s, completely different picture. The 2080 is not that very far away. 2080 kind of sounds like a really long time, but 2080 I think is quite tangible for a lot of us. 2050 is definitely there. And in 2050 we already see a shift in that food insecurity. And food insecurity leads to terrible things like conflict. Food insecurity leads to things like child malnutrition. Food insecurity leads to all of these knock-on effects. Okay, another area, biodiversity and ecosystems. Animals can move, right? So they have legs or wings or fins or whatever, slime trails of snails. Animals can move. They can't move very fast a lot of the time, and often they're restricted in where they can move because of cities or because of roads or because of whatever else, geography, rivers, but they can move. Plants find it more difficult to move. You don't see plants just kind of uprooting themselves and going 10 meters over there. They do though. Both plants and animals are migrating due to climate change. So plants and animals are very sensitive to temperature. And so what we're seeing is that species are moving. And because everything is connected, I keep on bringing it back, that's going to have knock-on effects. This is leading to shifts in ecosystems. So where things normally live is going further north or further south, depending which side of the equator you are. It's leading to extinction. We're in the sixth mass extinction of our planet's history. And new threats and diseases as previously alien species come in. So new species are coming in, the ecosystem has no idea what to do with them. Suddenly a ton of animals that were totally safe are being eaten or killed or poisoned or whatever, it's tipping things. And lots of different issues come from that. So this is one of my favorite videos in the world. I've played it like 10 times now, but I'm going to play it for you because I think it's a beautiful way to see the ways in which we're all interconnected and can have impacts.
Scientific findings of the past half-century has been the discovery of widespread trophic cascades. A trophic cascade is an ecological process which starts at the top of the food chain and tumbles all the way down to the bottom. And the classic example is what happened in the Yellowstone National Park in the United States when wolves were reintroduced in 1995. Now, we all know that wolves kill various species of animals, but perhaps we're slightly less aware that they give life to many others. Before the wolves turned up, they'd been absent for 70 years, but the numbers of deer, because there was nothing to hunt them, had built up and built up in the Yellowstone Park, and despite efforts by humans to control them, they'd managed to reduce much of the vegetation there to almost nothing. They just grazed it away. But as soon as the wolves arrived, even though they were few in number, they started to have the most remarkable effects. First, of course, they killed some of the deer, but that wasn't the major thing. Much more significantly, they radically changed the behaviour of the deer. The deer started avoiding certain parts of the park, the places where they could be trapped most easily, particularly the valleys and the gorges. And immediately those places started to regenerate. In some areas, the height of the trees quintupled in just 6 years. Bare valley sides quickly became forests of aspen and willow and cottonwood. And as soon as that happened, the birds started moving in. The number of songbirds and migratory birds started to increase greatly. The number of beavers started to increase because beavers like to eat the trees. And beavers, like wolves, are ecosystem engineers. They create niches for other species. And the dams they built in the rivers provided habitats for otters and muskrats and ducks and fish and reptiles and amphibians. The wolves killed coyotes, and as a result of that, the number of rabbits and mice began to rise, which meant more hawks, more weasels, more foxes, more badgers. Ravens and bald eagles came down to feed on the carrion that the wolves had left. Bears fed on it too, and their population began to rise as well, partly also because there were more berries growing on the regenerating shrubs. And the bears reinforced the impact of the wolves by killing some of the calves of the deer. But here's where it gets really interesting. The wolves changed the behaviour of the rivers. They began to meander less. There was less erosion, the channels narrowed, more pools formed, more riffle sections, all of which were great for wildlife habitat. The rivers changed in response to the wolves. And the reason was that the regenerating forests stabilised the banks so that they collapsed less often, so that the rivers became more fixed in their course. Similarly, by driving the deer out of some places and vegetation recovering on the valley sides, there was less soil erosion because the vegetation stabilised that as well. So the wolves, small in number, transformed not just the ecosystem of the Yellowstone National Park, this huge area of land, but also its physical geography.
So the importance of this video, this is the wrong slide. Excuse me, sorry, here we are. Okay, what do you think?
Amazing.
Amazing, yeah.
Mind-boggling.
Right? Okay, good, I'm glad I'm not the only one.
So there is hope that things can be reversed.
Yes.
Things can be reversed.
Yes.
Yes. Everything is connected and there's systemic ways in which we connect to everything that we do. So if wolves can be reintroduced and rivers can change course, the importance of ensuring that we're thinking about ecosystems and biodiversity is giant. It's really easy to think about food and water and the impacts on us as humans, but the ways in which ecosystems and our rest of life on Earth impacts us is also hugely important. And it's positive because it shows that changes can lead to good things, but it's also really valuable because it shows the ways in which it's all connected and we need to value it as an impact. Okay, some other examples of things changing. So this is a map which shows lobster, hake, and sea bass. So that's like some marine species, some fish, lobsters, they're like big clawed things. And from 1968 to 2015, we've seen them moving north. This is the east coast of Canada and the US. And the dots show where they've gone from. So 1968 they were here, and 2015 they were found here. This is about 168 miles, I think, is what they talked about in this paper. 168 miles for a lobster is a really long way. And of course, it didn't happen for just one lobster. It's where they're found in general. It's the trend. It's the same way as with looking at climate rather than weather. We're seeing the average. So these animals, the red hake is moving north as well. You can see the blue dots. The lobster is going from here to here. All of this is because of the rising temperatures. They need a very specific marine climate to exist in. And from 1968, they have been going north. If we think about the ways in which the ecosystem of the wolves changed with such a minor tweak, think about what happens when all of these species start moving. Think about how that's going to impact exponentially. Another example, the Coma butterfly colonizes Scotland. This is the Guardian article. And the British Coma butterfly has moved 137 miles north in the last 2 decades. 137 miles is a pretty long way for a butterfly. It's going to Scotland from somewhere in England, I don't know where it was found. The Coma butterfly is going to have another impact somehow. We don't know. The uncertainty of it is also kind of terrifying. It's really important because we don't know what happens when we put these new species or find these new species in these different ecosystems, what those effects will be. It could be good, it could be bad, it could be anything. And this is the mountain pygmy possum. It's dying of starvation in Australia. How cute it is. Species are becoming extinct. It's dying of starvation because maybe something like the butterfly that it ate has suddenly started moving north, and it hasn't moved north. And so these species are having knock-on effects. This is one fear of mine. The Asian tiger mosquito is coming for northern Europe. Can't even look at it without feeling terrified. Mosquitoes bring things like annoyance and a lot of like slapping in the night and hitting yourself in the face trying to get rid of them. But they also bring things like disease, malaria, dengue, I don't know what else we can get from vectors. So mosquitoes and other species are going to cause problems for people and for ecosystems. Okay, let's move on to water. Depending on where you are, climate change and water have a lot of different effects. Focusing a little bit on India, glacial melt and retreat. So I've been to Ladakh, I've been to the Himalayas, I've seen how beautiful your glaciers are. 67% of them have retreated in the last decade. Glacial retreat essentially means that every year, normally in the summer, a glacier will melt a little bit. It provides fresh water to people, it feeds ecosystems. But then in the winter, it will snowpack again, and that glacier should remain constant or growing. Retreat is when it does melt, but then it doesn't have that snowpack enough to go back to where it was. So it's shrinking, essentially. They're getting smaller and smaller and smaller. And with getting smaller and smaller and smaller, less and less and less opportunity for fresh water. Less and less opportunity for us to benefit from the glaciers. And of course, changing ecosystems, changing all of these other things that are happening too. So 67% of them have retreated. Depending on where else you are in India, droughts and flooding are projected to rise significantly. For this city, flooding is a major issue. And conflicts, like we already mentioned. So when we don't have enough water, we get really, really annoyed. This is another Guardian article showing that 8 billion tons of ice are being lost each year and not replaced by snow in the Himalayas. So that 67% is 8 billion tons of ice melting and going. Like, we're using it, great. It's going into our water cycle, but it's not going back into those glaciers, which means that in however many years' time, when those glaciers are gone, we're going to have real issues. This is what it looks like. So this is the location of the glaciers. India, Tibet, Delhi is here, so you have the line of them all along this mountain chain. The blue line here shows the glaciers from 1975 to the year 2000. And this is the average meters of height loss per year. So you can see it's going down, it's going up, it's going down a bit, but it goes up and up and up. So between 1975 and 2000, it was fluctuating. But then if we look at 2000 to 2016, for the same places, it goes down, it goes up, it goes down, 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 down. So this is the glacial region here, whereas at the level it was in 1975 to 2000, now it's at this level. And again, lower, 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 and we're at at 0.4. I can't actually really read what that says. Essentially, what it's showing is that there is less mass. And it causes problems worldwide as well. So Cape Town last year was talking about zero water. They had a timer. When is the city going to run out of water? It's almost incomprehensible to have a city without water. We use water for so many things. It's going to have connected effects. So it's going to affect the economy. It's going to affect trade, food, the ways in which we grow things. It's going to create conflict. It's going to create things like the Arab Spring. There's a lot of people who think that the Arab Spring, a giant conflict which is having repercussions to this very day, is because of water. This is food prices and the Arab Spring, looking at the ways in which food prices and because of water changed and how it correlates. And bread prices set to soar because of wheat, because of drought. All of it connects. Okay, so that was temperature increase. Let's talk a little bit now about those extreme weather events and how the intensity and the frequency of them changing will have effects. So we have droughts, we have heat waves, we have floods, storms, wildfires, not flyers, and snowstorms. These are just some extreme weather events. India, here she is. This is the climate risk index. The darker color is the higher risk, lower color is lower risk, and we're about here. Let's make it a little bit closer to home. You probably all remember this. This is Cyclone Fani. This is Odisha, which is south of here. Let's see what the cyclone did. Showing you this because you probably lived some of this. For me, monsoon is something that's very far away. Cyclones are, fortunately for me, something that I don't experience. But if you have experienced it, and if you know what it's like, or if you see in this video, it's probably terrifying, and it kills people, and it destroys cities, it destroys homes. All of these things are increasing, and Kolkata is a megacity, and it's a megacity which the IPCC and the Asian Development Bank specifically identified as a hotspot for climate risks. This is because of the geography. We're in a low-lying area in a delta near rising sea levels, and this is also because of the vulnerability of populations. It's because of the infrastructure. So there's a lot of ways in which places that we live in have very real impacts. Sorry, that's a little bit too high. This says, Kolkata is becoming an unnecessary climate causality. It doesn't have to be. This is an article in The Independent. They talk about the ways in which the sewage and drainage system is blocked. You're going to have to tell me more about this, because this is just me doing a little bit of background reading.
So, a little bit addition to the IPCC report, he points out that by 2050, Kolkata is at rank 1 in terms of risk because of asset, and at 3 by the size of population.
Okay.
And what you see here is because of Kolkata doesn't have any of these sewage treatment plants.
It doesn't have any what?
Sewage treatment plants.
Sewage treatment, yeah.
We don't have any artificial sewage treatment plants, which cities all across the world have. We still depend on a natural sewage system, which we put on the wetlands.
Okay, yeah.
And as they get encroachments and get affected, there will be no place where this water can go.
Right, so urban sprawl, more and more people need more space, and we're taking up the space where the water is naturally absorbed.
So unlike the solid waste, which can be dumped one after the other, the liquid waste always will spread.
Yeah.
That's the reason why we are most vulnerable to flood and sea level rise.
Great, thank you. Yeah, exactly. This is exactly also what the World Bank is saying. The same thing. By 2050, almost 40% of the city area and 47% of the city's population, close to 25 million, could be affected as a consequence. This is a very real thing for all of you. And finally, rises in sea level. So we've had hazards. I don't want to go too much into it because it's just too depressing. So I'm just going to go to rises in sea level. Let's see what that will do. This is a short clip that shows you a little bit how it's happening. To our governments, the ways in which we as citizens can also advocate for and lobby for change, because there is awareness. People know, you guys are all aware about these things, and so then we can start thinking about what that can look like in terms of adapting to that, mitigating that. This is Arctic sea ice, 1984 to 2012. All of that has gone into the oceans. That's a lot of difference. If we look at how big this is, and if we look at it in 2012, all of this is new, uncovered, uniced area. This is oceans and sea levels. 40% of people live on coastal areas across the world. These red things are hot spots where there's cities and people living in river deltas and coastal areas. And it doesn't only cause sea level rise, which means flooding, but it also leads to coral bleaching. It leads to changes in ocean currents. Again, more and more connected impacts. This is a paper I just read 2 hours ago. It was published in 2018. The trend of sea level rise on the West Bengal coast. So this is what it's showing for Haldia, kind of near here. It's up here. Yep, so we see from 1970 to 2015, sea level rise on average increasing. If we look at Diamond Harbor, it's also kind of near here, right? We're looking at 1950 to 2015, again, average trend, rising sea levels. And then the final one, Garden Reach. If we look at from 1930s when they started monitoring sea levels to wherever we are now, 2019, look at the ways in which we've gone from 6,800 millimeters to 7,400 millimeters. This is what all of the science is showing. It's real, and there's so many people who might tell you that it's not, or really just have a certain ambivalence. They're able to turn off, and you can use the science, you can use facts to show them that this is occurring. It's going to cause migration. 140 million projected to move because of climate change. The figures change because it depends on how you define it. So moving because of climate change directly, indirectly, voluntarily, involuntarily. Essentially, it's a lot of people. A lot of people will have to move, and that's not necessarily bad, but the ways in which we support them to move and the ways in which we accept them to the new places they have to go really need a lot of thought. This is a really beautiful photo essay, so if you want these slides, there's a link to the photo essay showing what it means for people to move. It's going to have effects on human health. We've talked about diseases, heat exhaustion. People are going to die from being too hot. Storms and weather, again, is going to cause deaths. Okay, let's take a deep breath. Please take a deep breath with me, because this is a lot of really, really intense and kind of totally hugely depressing information. Okay, it's not totally hopeless. All of you in this room give me hope that it's not totally hopeless. Hope, but not hopelessness. All of you are engaged, and I think actually now what we should be doing is talking to one another. So what I'd like to do first of all is I want you to take a minute or two to talk to the person next to you, maybe talk to the person behind you. Let's think about what vulnerability is. Because climate change, again, it's not fair. It doesn't act in a fair way, thinking about who has had impacts before, and maybe it's this person's turn now, and you know, over there, you've got a huge capacity to cope, let me hit you. What is vulnerability? Why are megacities vulnerable? Who is vulnerable? How does vulnerability interact with climate change? Have a small discussion for maybe 2 minutes with the people next to you, and I'd like to kind of feed back to the group, and just to get an idea of what we understand of vulnerability, and then we're going to do some more kind of moving around. Go. And introduce yourself. If you don't know them, introduce yourself, tell them what you do, tell them why you're here, give them a bit of a picture.
Hello,